Well, it had to happen. I had to come to this part sometime, and that is the FM alignment of this radio. I've done a bit of experimentation on the alignment here, and I found that two of the actual alignments were quite a bit out in terms of talking about the IF alignment, of course, and I made some adjustments and it seemed to make quite a difference. So what I've done is I've actually put it back to where it was, so that I can go through it with you and have a recording of this, even for my own reference, because that's always something I like to keep. Now this thing comes with a pretty easy to understand set of instructions for the alignment. It's actually got the German and it's got the English version as well. And so this was actually less of a challenge than I thought, because it does actually explain what what you're supposed to do, and it gives you a fairly detailed description of what it is you have to do. Now, the first thing they tell you to do is to set up the metering equipment in a very specific way. What they tell us to do in preparing for the FM alignment is to connect a VTVM to the radio electrolytic condenser for indication of the AVC voltage. Connect the zero instrument from the connection point R30C60 to ground. Then you put a signal generator and modulate it. This would be at the frequency they would stipulate. And align at 2 volt AVC voltage. Neutralization trimmer C11 is set and at the factory, blah, blah, blah. Okay, so not that difficult to understand. They talk about a VTVM because they want a high impedance. You want a high impedance input to read this voltage and not affect it across the ratio electrolytic condenser. Now that is fairly easy to find. If we look at that section there, that is the ratio electrolytic condenser. It's actually reads a negative voltage if you measure it under conventional terms, but this is your ratio detector. There is that coil with a center tap that's obviously very obvious in all FM receivers, and this is the one to be afraid of if you're going to be afraid of anything. This is the one that generally would require a visual alignment technique, meaning you'd need a sweep generator. In the old days, they used to use something called a wobulator. I don't have that. I don't want to get into that. But fortunately, the way they describe it here, you don't need any of that. They actually describe very accurately how you're supposed to do it. So you measure this voltage here. This voltage is actually the same voltage that is reflected on the magic eye, and it's actually giving you an indication of the strength of the received signal. So you're measuring a DC voltage which is proportional to the strength of the signal received. So if all your circuits back from this section are perfectly aligned, you'll get the highest voltage there. One thing that becomes obvious is because it's an electrolytic, you have to be very careful because it is not an instantaneous response. There is a little bit of lag. So effectively you have an AVC lag. It's not very great, but you do have to be careful that you don't try and do this too quickly, or you might miss the peaks. This capacitor effectively charges and discharges, and there is time to do that, so you have to give it a bit of space. And measuring that is quite easy because it's easy to find in there. So we'll do that, and I'll show you where that is inside the radio. The next stage says connect the zero instrument from the connection R30C60 to ground. Now, they have a schematic here where they actually show you where to connect the zero instrument, as they call it. And it says R30 there. And it says C60, which is over there. So you've got about a 300 picofarad capacitor, 100 kilo ohm resistor meeting a 300 picofarad capacitor, and that comes from a 47 ohm resistor and a 270 to ground. The problem is we don't have that resistor in this schematic that I have here. It's labeled differently. We do have the resistor, it's just labeled differently. And here it is. There's our center tap. So if we compare the two, it comes off the center tap to a 47 ohm. That comes off the center tap to 47 ohm. It then meets a 270 picofarad and 100 kilo ohm. There it's labeled R30. Here it meets a 47, it goes through a 47 ohm, which meets a 100 kilo ohm and a 270 to ground. So my guess is that is the R30 they're talking about, which here is labeled as R29. That carries on down and it meets a 500 picofarad to ground. So after this 100k resistor, at that point is where I would connect the zero instrument, as they call it. Although obviously the numbering is different, and this is called C60, but it's a different value. It's 500 picofarads, and over there it's 300 picofarad. So we have to connect this so-called zero instrument effectively at this point. Now what they mean by zero instrument would be a microammeter, which is set on the middle of the scale, so that if you have a positive reading, it goes right. If you have a negative reading, it goes left, and you're supposed to set it till it meets in the middle. I don't have a zero instrument, or zero reading, whatever they call it, zero-centered instrument. I have obviously a microammeter, and my logic was that if you have a microammeter that reads from 0 upwards, you can always reverse the polarity on it if it's going negative. Now, I just have to find these points on the radio, set it up, and the next stage is to feed it with a signal generator unmodulated. It's quite clear down here as to what that signal would be. It's 10.7 megahertz. It's the IF frequency. It's also clearly labeled on the cans themselves. And then you have to adjust the respective coils. What it also says is that you have to align at 2 volt AVC voltage. Now my guess there would be set your measuring device here. They ask for a VTVM. And when they say set to 2 volts AVC, what I believe they mean is adjust the strength of the incoming signal so that you get to about 2 volts across that capacitor. Okay? And then obviously you keep reducing the strength of the signal as you align, and as the signal gets stronger, you reduce the strength of the signal to keep it around 2 volts so that you don't overload the preceding circuitry. Here's the English table. FM alignment, the alignment of the IF, they've left it in German. There's a little asterisk which says detune L27 considerably, example, in other words, turn out the iron core. Now L27 is a scary one. L27 is that one there. That's the one you then have to align to give you a 0 reading on the microammeter. What I'm going to do, and I haven't done this testing with this detuned, is I'm actually going to detune it. I'm going to count the number of turns that I'm detuning, just in case I do something wrong. At least I can get to the ballpark before I start looking for any meaningful measurements. So you detune L27 and you find a free spot on the dial. You feed it 10.7 megahertz at a level that gives you about 2 volts AVC voltage across that capacitor that you're reading. Where do you connect it to? They call it the screening of ECC85. Now that is the tube inside the FM casing over there. There's actually a metal screening that's soldered to the casing. I'll show that in a minute. Feed the signal to that. Obviously you have to desolder that desolder the screen that's connected to the casing, or otherwise you're just getting a 0 signal. And then you have to play around with L26, 23, 22, 21, 20, up to 4. Now what we're doing here is, here's L26. So we're aligning backwards from this point back into the radio. We're aligning this one over here first. Then we go to the preceding ones. So here we are. There's L26 over there. Then we do L23, which is that one. Then 22, which is that one. 21, 20. And then they talk about L4 and L5. That is inside the FM can. That's L3 and, beg your pardon, there's L4 and L5, and that is the ECC85 tube, into the screen of which you are feeding the signal. Okay, it all seems pretty simple. Murphy's Law is things can go wrong. Let's just hope they don't. So we'll give it a try. The first step is to find the connection point into which the signal is going to go, and it says the screen of ECC85. Now the ECC85 is that tube there. The screen is the screen that they have over the top of it, and it was, because I have disconnected it, it was soldered to the casing here, so the shield gets soldered to ground, obviously to give it the best effect as a shield. And what I have done is desoldered it, so we now have that free. I move it slightly back so there's no chance of it touching the ground, and I'm going to connect the signal to that point over there, so we've got the signal going into the shield. Let me just put it that way. There we go. It's not touching, it's separate, it's still covering the tube, so the signal going in here will get radiated into the valve, into the tube, and we don't have it shorted to ground, because obviously the cold side or the ground side of the signal itself will be connected to the chassis, which is ground. So here we have the signal going into the screen of the ECC85. The black lead is the ground of the signal, which is connected to the chassis. The red lead is the signal itself. It's just touching or connected to the screen, so there's no DC connection. Therefore, this is actually doesn't use a capacitor between the signal and the actual screen itself. And there we have the capacitor, that electrolytic capacitor. And across that electrolytic capacitor I have the two test leads connected. Those test leads then go to the voltmeter, which at the moment is connected directly. And here's the voltmeter reading. It's on the 10 volts DC range. It's reversed because this is actually a negative voltage that it's reading. It's the AVC voltage, and it's actually reading about 2.5 volts. And the reason I know that that's working is I'm feeding a 4 millivolt peak-to-peak 10.7 megahertz signal in. And if I change that, if I increase it to 5, to 6, to 7, I notice the strength of that signal increasing as well. So I know that I've got my meter connected to a point which is directly related to the strength of the voltage, or of the signal coming through the radio. So I have it set to 10 volts. I'm going to put a buffer between it, just something that I built. It's a little op-amp buffer for DC and AC. This is just a very high impedance buffer. We'll probably see a higher reading on there because the meter is actually dragging down the voltage somewhat. It's acting as a load. With this we end up not seeing that effect. So, slight change of plan. The buffer that I put in there obviously has got something wrong with it. It was introducing some hum and messing up the reading. So I have a different multimeter here, still analog, but higher input impedance. And so let's get started. The first thing to do is to detune L27 considerably, and L27 it's over here, so it's the can closest to the power transformer from the back, and it is the bottom group, second group, one to the right. So that's L27 over there, and I'm going to detune it in a bit of a controlled fashion. I'm going to actually see how many turns I take to get it out of tune. I don't know if it actually affects the AVC at all, but we'll see. Right, I've actually unscrewed it about 7 turns, and we'll see what effect that has later on. I have to then get it back to a null point later on. So the next stage is to tune L26, 23, 22, 21, all those up to L5 and 4 for maximum AVC. Now L27 was that one, L26 is there, 23 is there, 22 is there, 21 is there, 20 is there, and then the 5 is on the top, which we'll see in a second. So I'm going to try and adjust those for better AVC voltage. Well, that's obviously, there's a peak. That one was slightly off. There's a peak. That one is stuck. And because it's stuck, I'm not going to force it. I'm just going to leave it. Probably the wisest thing to do. You don't want to mess up any of those transformers, break the cores, and then end up with a bigger problem than you had to start off with. There's another one. There's the peak. Right, so they're all peaked, and very little change, very little improvement, because I hadn't done that before when I tested it. The next one is L5 and L4, and these two are on the top of the FM can. There's L5, there's L4, so I'll tweak those and see if there's any difference. Shouldn't be much because it's pretty much spot on. Very slightly there. There we go. So they were all pretty much peaked. This is more an experiment to show how it's done than anything else. Now, the last stage is to redo what we did with L27, which is still in the same, you're now trying to adjust the ratio detector. Same position on the dial, 10.7. Everything else stays the same, and we adjust L27 to a null point. Now for that, I'll connect the microammeter to those points there. After that resistor, that 100k resistor, and to ground, and we'll get that annulled by adjusting L27, which is the one we detuned. Let me set that up. So what I have there now is I've set the meter in its position. I actually have the reverse polarity on here because it was measuring negative. So I'm going to fiddle the L27 till I get that to 0. See, there's a peak both ways. So that's going down. And you see it goes further down, so I can reverse the polarity. And I should get a peak the other way. Alright? So effectively, if I get it down to 0 there, I've got the null point. There we go. That should be it. So I think the scary process is terminated. I don't expect any change because I'd done this before and did notice an improvement then. The magic eye started closing further, meaning that the signal strength coming through was improved. I wasn't so certain that I wanted to do this, but I experimented and I decided that if I really want to get to know everything about this radio that's had to be done. Now, if you recall, there's also these alignments. These are the RF alignments, meaning we can then adjust the oscillator coils and capacitors to get the dial aligning with the actual frequency. However, because I've changed this to catch the 101.6 megahertz station that I wanted, I've actually put this out of whack on purpose. So obviously I don't want to realign this. It's not going to align with the dial, and I know that's one of the characteristics of the radio. I can always go back and improve it later if I want, put it back to the original. But as mentioned before, this one only goes up to 100 megacycles, 100 megahertz, and I wanted 101.6. And I'm catching the 101.6, and I'm getting the lowest station we have here, which is at 88. I'm getting that at about 87, which is the limit of this radio as well. So that seems to be it. That seems to be the IF alignment, the RF alignment, rather the IF alignment of the FM done. And I must admit I was a little bit nervous when I first started messing around with this particular part of the exercise, because I was afraid I was going to make it worse, and sometimes that does happen. Generally, these radios don't need much alignment on the FM, and very seldom do they need much alignment on the AM as well. But to get the whole exercise done, to get this thing doing what I wanted it to do, and being confident in doing this again in the future, I had to do this sometime, and I guess this was it. All right, hope you enjoyed that. Right, I think it's time we put this guy through its paces and test the reception. So first things first, let's try long wave, which I don't expect to receive anything. I only receive, other than all the tech noises, I sometimes receive a French station around 160 kilohertz. It's not there now, not surprising. And let's try medium wave. Now, medium wave has two modes of reception. One is using the normal external antenna, and the other one is actually using the internal ferrite antenna. I'll go through the normal one first. We get a lot of noise. I have very few stations of medium wave anyway. There's the Spanish station from the Canaries. And if I put in the ferrite antenna, I can then adjust it for the best reception, and I get a much clearer signal. There's our local AM station, 1. And adjusting the antenna improves reception, obviously. When I say adjusting the antenna, rotating the internal ferrite antenna. If I take off the ferrite antenna, this one's particularly strong, so it does receive it quite well anyway. And you can see the magic eye does work. Right, let's try shortwave. Shortwave does not use the internal ferrite antenna at all, but it gets incredibly good reception.
Экономичной, довольно строгой монетарной экономичной политики.
Он посеял в уме человека отрицательные мысли.
ينفعهم في الدين
Again,
والدنيا.
you can see the magic eye.
صلى الله عليه وسلم فقد غير واحد من المفسرين أن الله تعالى أمر نبيه صلى الله عليه وسلم
It's actually got pretty good selectivity because there are a heck of a lot of stations packed together in these bands.
When I wrote a letter to her to express my gratitude, I was so excited.
Yang books, from Fortress Besieged, Brief 3 to Don Quixote, which was translated by Madame Yang.
That side of the band is pretty deaf at this time of the day. So with FM, there's my 101.6.
Por toda a Europa, ainda que tem séries muito características e muito...
Conceito, pois dele depende o seu sucesso empresarial, profissional.
Perfect sound.
É hoje então, e ginásio, temos six-pack para hoje ou não? Bom dia. Alimentá-la. E é no estado que se dá de comer. É respirar o mesmo ar.
So that's the lowest station. It's usually 88. It's now probably around 87. So the whole dial has been shifted, which is fine for my needs. That one there is another one of the major stations, and that is at 88.3 when in fact it's 89.3. Now another thing that this one has is this automatic function for tuning. It's a sort of auto tune function, and you can see how it tunes out, and if I activate it, it stays perfectly tuned for a bigger part of the band. Get away from music, otherwise I'll get hit with a copyright. So treble works pretty well. Bass works too well. You normally have to reduce bass a bit. This is for speech. It brings out more of the higher frequencies. And that's about it for the radio reception. So, in summary, I have what is probably the most sensitive shortwave reception on this radio that I've ever had, including on the SABAs, which I thought were amazing. If there's a fault, it's that there isn't really a fine-tuning function, which would be very useful because these stations can be very packed on this band, on this span of the shortwave. So a fine-tuning would have been useful, but it doesn't have one. So you have to really be very sensitive when you tune, but it receives stations incredibly well for where I am anyway. I've received just about stations from just about everywhere in the world, really, and which is surprising because they come through pretty clear. Most of the hiss is cut out, so in terms of selectivity and sensitivity, this is incredibly sensitive and selective. That's the shortwave. This one is also it's pretty easy also to pick up some of the amateur bands, like the 20 meter band on 14 megahertz, 14.1 megahertz. I sometimes pick up some of the garbled quacking sounds, and I switch on the signal generator, the frequency tune in, and I can pick up the amateur bands quite well. So that's shortwave. Medium wave is very, very good for the few stations, or the one station that I have in Madeira, and some of the Spanish stations from the Canaries. The Canary ones always work better with the internal Farad antenna. The local one seems to work better with the external antenna, probably because it's a stronger signal. The long wave, I get very, very little. In fact, I recall receiving 2 stations on this at most. Both of them French, strangely enough. They seem to like their long wave. And on FM, this radio is amazing. It's hi-fi FM, if you can call it that. It receives incredibly well. Music is incredibly precise and clear. No hiss, no noise. I am incredibly satisfied. That's about the 4th time I've used that word. Very, very satisfied with the FM reception here. It's a sort of reception that I would use at home normally. So this radio will be used, not only for the amplifying section, which I've gone through before, but also for the FM reception to listen to music on. And I'm sure that it's going to give me many, many hours of satisfaction in the future. Now, the only outstanding part is the cabinet and the gramophone, or the record player. So that's the next stage, and then I'll be able to wrap up this project. So we have one more stage to go, and that should be it. Hope you enjoyed it so far. Bye for now.